What is up, you guys? My name is Josh, and I am Mrs. Crowley's oldest son. In the past, I have come into her class around this time of year and done a little science lesson because I love science, and done a science experiment with her classes in the past. Obviously, because of the coronavirus situation, probably not going to be able to come in and do that in person, so I thought I could make a video and kind of do the same lesson and same experiment, and you guys can watch it at home. So I hope you enjoy it. The lesson is going to be super short because I want to keep the video short so that we can get it sent out to you. But I hope that you learned something from it. So I just really quickly wanted to teach you a couple of terms and then explain the experiment that we're going to do. So the first term is a chemical bond. Okay. So we're mostly talking about chemistry today. So a chemical bond is the force between two atoms that makes them want to stick together. So I know this year you guys have learned a lot about magnets, and you've learned about how there's a north pole and a south pole, and that each individual magnet has a pole and that opposites attract, right? Well, molecules also have poles. They also have electrical forces, which makes them want to stick together. It's pretty similar, actually. And so a chemical bond is kind of that attraction between two molecules or two atoms that makes them want to stick together. Okay, so that's our first term, is a chemical bond. Our second term is a chemical reaction. Sorry, this is probably super crooked. It's hard for me to write off to the side. So a chemical reaction is when a chemical bond is either formed or broken. Okay, so anytime you see like somebody mixing stuff and something happens, that's chemical bonds being formed or broken. Okay, and this happens in cooking, this happens in our bodies, this happens all around us, and usually there is energy transfer as part of this reaction. Okay, so our third term is activation energy. Okay, so activation energy means the amount of energy that you need in order to make a chemical reaction start. Okay, so you can kind of think of it like when your alarm clock goes off on Saturday morning. What is it that's going to get you out of bed? Is it the promise of a good breakfast? Is it that you have something that you have to go to? Is it that you know that you're going to hang out with your friend that day? What is it that gets you out of bed? That would be your activation energy, is what gets you out of bed. In chemistry, it's usually like heat or it's motion. Most often we use heat, and so that's what activation energy is the amount of energy that you need to make a reaction start. Okay, and the fourth term is catalyst. Okay, so in chemistry, a catalyst is something that we add to a reaction to reduce the activation energy. Okay, so it's not technically used up in the reaction. It's actually just there to make it so that whatever we're mixing together, the reaction happens sooner and with less energy. So let's say like for a certain reaction, I need it to happen at 150 degrees. If I add a catalyst, maybe I can get that reaction to start at only 100 degrees. So that's what a catalyst does. And you'll hear this term used in other ways. So like you in your class can be a catalyst for learning by listening to your teacher and doing what she asks you to do. Or like in your situation right now, you can be a catalyst to your learning by putting forth the effort to do the online material. That's like being a catalyst. Okay, so it's like learning is happening because you are helping that process move along, if that makes sense. So those are our terms. So let me tell you a little bit about the reaction that we're going to do. So it's actually really simple, but it's really cool. So there's this stuff that you may have heard of called hydrogen peroxide. Okay, it's often in a first aid kit. So the chemical formula for hydrogen peroxide is H2O2. So you've heard H2O, that's water. H2O2 is almost the exact same molecule as water, but it has an extra oxygen. But guess what? Hydrogen peroxide molecules are not happy. That extra oxygen does not want to be there. It actually wants to be in the air. It wants to be a gas, okay? And so it really wants to break apart and just become H2O plus O2, okay? That's what it wants to be. So with our reaction today, what we're going to do is we're going to mix this hydrogen peroxide with soap, and then we're going to add a catalyst, which is yeast. And what the yeast is going to do is it's going to make it easier for this extra oxygen molecule to break off and make our water plus oxygen. So now I want you to think, if you have water and gas and soap, what would that make? It makes bubbles, right? And it makes them fast in this case. It makes a lot of bubbles really, really fast. But here's the trick. I'm going to put it in a bottle, and I'm going to seal that bottle so that, and actually, here's a little quiz for you. I know you guys learned about states of matter this year, right? Solid, liquid, gas. So if you can remember, a liquid takes up less space and has less energy than a gas, okay? So a gas wants to spread out as far as it can, and it moves much faster, okay? So this oxygen molecule, when it's in the liquid form, in the hydrogen peroxide, it's okay being in a smaller space. But as soon as it becomes gas, it wants to spread out more. So if we're changing a bunch of this to become water and air, oxygen air, it wants to spread out. But I'm sealing it in a bottle, so that builds up pressure, okay? And then what I'm going to do is I'm going to put that bottle with 3 little spokes on the side, basically, and I'm going to turn it over so it's standing up like a rocket. I'm going to put a cork in it, and as soon as that pressure gets so much that it pushes the cork out, boom, it's going to explode upward, okay? It's going to be super fun. Hopefully this all made sense to you. Hopefully you learned something about science. And yeah, let's go do it. Okay, so I'm getting our reaction all set up. So what I'm going to do is I've got this hydrogen peroxide. It's a little bit different than the kind that you have in your first aid kit. It's actually for bleaching hair, and it's much stronger, so it's going to give us a better reaction. I've got our soap over here that's going to create our bubbles. So I'm going to mix those into these bottles, and then in a minute I'm going to mix this yeast in, which will be our catalyst that will lower the activation energy, cause lots of bubbles to be made. And then I'm going to show you, and I want you to create a hypothesis of what's going to happen. So we have 4 different bottles, and they're all different shapes and sizes, okay? So I want you to predict, I got it. I want you to predict which one is going to go highest, okay? So think about, all of the different things at play. So how heavy is the bottle? How much room is there in the bottle to build up pressure, right? So a smaller bottle is probably going to build up pressure faster than a big bottle. But a big bottle, by the time it explodes, it might have a lot of pressure in it. So let me show you the bottles. So we've got this one that's probably the tallest, and you can kind of see how the neck of the bottle is kind of comes, it narrows. So I'm hoping that it explodes pretty high. I'm not sure. Just normal Dr. Pepper bottle, pretty similar, but a little bit smaller. Then we've got this bottle that I thought the neck might provide some good lift. I don't know, not sure. I think it's a little bit heavier. And then we've got this one that I'm pretty excited about, although I'm not totally sure how well I'm going to be able to screw the lid on, because this reaction happens pretty fast. And with these ones, I'm just going to put a cork in it, the ones that I just showed you. This one, I have to screw this lid on, but it's a really small spout, so that should create the most lift if I can screw it on in time before it just leaks everywhere. So we'll see. So I want you to make a hypothesis of which one's going to go the highest. There's a good chance that some of them won't even work, or that I won't be able to get the cork in time or the lid on. We'll just have to see. But that's part of science, is we just do our best and see what happens. So let's go outside and give it a shot. Oh, baby. Oh, come on. What? Oh, no. Oh, no. Come on. Whee! All right, so that was fun. I learned a few things from that experiment. So as you could probably tell on the very first one, I couldn't get the cork in the bottle fast enough before the reaction had started. And then I needed to push the cork in to get a good seal, turn it over, and then get back as quick as I could. And I just couldn't get away fast enough. So then what you might not have been able to see very well in the video is that I figured out a way to use plastic baggies to put the yeast into, to temporarily prevent the mixture from, or to prevent the hydrogen peroxide and soap mixture from meeting the yeast until I flipped it over. And that worked way better. So I'm going to try all of them one more time. The other thing I learned was that these two bottles, so the kind of the soda type bottles, the Dr. Pepper one and the one I just showed you, the cork didn't fit very well, and so the pressure didn't build as much as it could. So this time I'm actually going to use their own lids, which is a little bit scary because I don't know. There's the potential that it could just explode outwards instead of the actual cap exploding off. We'll see what happens. But I'm going to try that, so we're going to video those ones as well. And then I'm all out of hydrogen peroxide at this point, so these will be the last 4. But yeah, I hope you enjoy it. Here we go. Oh no! All right, guys, so I hope you really enjoyed those reactions and the experiment that we did. I hope you learned something. I did just want to share a quick little story with you to kind of wrap things up and tell you a little bit of my story really quick. So in high school, I took one chemistry class, okay, and I hated it. It was super hard for me. Even though I worked at it, I felt like I didn't get it. And then, so I went to college. I actually went on a mission, and then when I came home from my mission, I was trying to figure out what it was that I wanted to do, what I wanted to major in for my career. And I just knew that I could not take any chemistry classes because that one that I took in high school was way too hard. I didn't want to do it. Well, a series of events happened, and I felt like I really wanted to go into healthcare. I wanted to either be a doctor or a nurse or a dentist or something like that. I wasn't sure what, but I knew I wanted to do something like that. But guess what? Doctors and nurses and dentists, they have to take a lot of chemistry classes. And so I kind of gritted my teeth and I decided I was going to do it. Well, over the course of college, I ended up taking 14 chemistry classes, which is a lot of chemistry, and I ended up loving it. And that's why I wanted to teach you guys a little bit about chemistry today, because I love it so much that I even like to teach it now, and I use it every single day in my job. And so I guess I just share this because maybe there's something in 5th grade that you feel like you're not very good at, whether that's reading or math, or maybe you have a hard time getting along with people, or maybe you don't really like science, or whatever it is. Maybe there's something else that's really hard for you right now. I just want to tell you that if you stick to it and if you keep trying, I promise that you can learn that thing that's hard for you, because I saw that happen. And if I hadn't been brave enough to kind of face that chemistry fear that I had, then I might never have gotten my job, which I love. And so that's my message to you, is to just keep on keeping on. Stick to it, even if you feel like you're the kid in the class that just never gets it. you know, math is just super hard for you, or whatever it is, like, don't give up. Because to be honest with you, everything else in school came pretty easy to me. Chemistry was like the first time that I was like, I just do not get this. But that's part of why I love it, is because I had to learn. It challenged me, and challenges can actually be really fun if we're not afraid of them. And so that's my message. Again, I hope you had a ton of fun today watching these videos. I know that I did. It was a little bit scary at times when I wasn't sure how the reaction was going to go, but it turned out great. So thanks so much, and keep on keeping on.